For this video, we're going to look at a couple more advanced examples of graphing exponential functions. So with this equation, y is equal to 2 times 3 to the 4 minus x plus 1, notice that we're subtracting x on the inside. So the very first thing I'm going to do is rewrite this by factoring out the negative 1. Let me make just a little bit more room so that I can do that. And factoring out the negative 1, I would have 2 times 3 to the minus x minus 4, and then plus 1. And by factoring this out, it's much easier to see how the function is shifted left or right. So let's start with this 2 on the outside. That means we're going to vertically stretch by a factor of 2. And the 1 on the outside, that essentially references that we're going to shift everything up 1 unit. And then this minus 4 on the inside, since we're subtracting 4, I always think about which x value makes this expression equal to 0. And that would be positive 4. So that tells us to go to the right 4 units. And then lastly, we have this negative right here that's in the input. And that negative essentially means that we're going to reflect about the y-axis. So that is a reflection about the y-axis. Essentially, the x values are being swapped. If you had a 2 for an x value, now you essentially want the opposite of that, which would be minus 2. So it essentially flips the graph about this y-axis. So now that we have an idea of how this function is going to transform, let's think about how to actually plot it. So when graphing all these functions, I usually start by thinking about what the parent function, y equals, 2 to the x, looks like. And we know that this function goes through the point 0, 1. So that's this point right here. So what I usually do is just think about how is this point transformed. So to start, we know we're going to stretch by a factor of 2. So that's essentially going to make my y value jump up. So now that I'm at 0, 2 instead. And then I know that I'm adding 1 on the outside. So that's going to shift everything up, including my asymptote. So this point's going to move up 1 point, but my asymptote is also going to move up 1. Remember, the asymptote was at y equals 0. But now we have an asymptote at y equals 1. That's what this plus 1 on the outside did. And then we know that we're reflecting about the y-axis, but since this point is on the line of reflection, this point actually won't be changed. Other ones will. And essentially what this reflection does is that if our function originally was going to look like that, now it's going to flip essentially, and instead of growing, it will come down and decay. So that's the general idea of what this negative does. But when concerned with this point here, it doesn't reflect since it's on the y-axis. And then we have this plus 4 to the right, so we have to shift it 4 units right. 1, 2, 3, 4. So now we're over here. And so this point right here is the final point on our graph. And I'm going to put it in that original color that I used. Right here. That's for this equation right here. So that's essentially our starting point. And then from here, we know that we reflected it, so we expect it to come down, but we really need at least one other point to graph this. So what I recommend is just picking a point either one to the left or the right of this data point we have here. So I'm going to use an x value of 3. So when x equals 3, I'm going to plug that into my function, and I'd get 2 times 3 to the 4 minus 3, which is 3 to the first. So I have y is equal to 2 times 3 to the first plus 1, so that's 6 plus 1, which is 7. So when we have 3, that goes all the way up to 7, which would be up here. And I could pick another point right next to it, x equals 5. Then I'd have 3 to the minus 1, which is 1/3, so 2/3 plus 1, or 5/3. And that would be somewhere probably around there. So now we can finish our graph by just connecting these points, and it'll essentially just hug that asymptote as x gets bigger and bigger. And if you want, you can figure out the y-intercept, though it's probably going to be a pretty high number, so we're not actually going to be able to graph it. So this right here will give us essentially our best picture of what the graph should look like. Okay, now with that one out of the way, let's move on to the second, more advanced example. And let's think about what everything means individually. So that means we're going to reflect about the x-axis. Essentially, all of our y values are now negative. And then this 3 here means we're going to stretch by a factor of 3. And this minus 2, we can think what x value makes this expression 0, and that would be plus 2. So that tells us we're going to go to the right 2 units. And then this minus 1 on the outside here, this tells us we're going to shift everything down 1 unit. So again, when trying to figure out how to graph these, we're going to start with that parent function, y equals x squared, and think about its starting point, which would be through 0, 1, and we're going to see what happens to this point. So first of all, we know we reflect about the x-axis, so it's now going to go down here, and then it's going to stretch by a factor of 3, so it'll be 3 times bigger. Instead of 0, -1, we're now at 0, -3. And then we're going to shift everything down 1, including that asymptote. So the asymptote was at y equals 0, but now it's going to be at y equals -1. So that's y equals -1, our asymptote. But like I said, it also shifted our function down another unit. And then we have to shift it right 2. So it comes over here. And so that will be its final position. So I'm going to rewrite it using that same color blue, or a very similar color blue. Yeah, same color. So this right here is one point that is formally on the graph, that point 2, -4. So to figure out the next point, I'm just going to pick a value either to the left or to the right of it. So I'm going to use x equals 3. Since if I plug that in here, I'll get 2 to the first. So y would be -3 times 2 to the first minus 1. So -6 minus 1 is -7. So at that value of x is 3, y would go all the way down to -7. And if I chose x equals 1, I can plug that in here. I'd get 2 to the -1, which is 1/2. And then I'd have -3 halves minus 1, which is -5 halves, or -2.5. So that would be somewhere around here. And then it's essentially just going to look something like that. So that will give you a rough idea of what this graph should look like.